The last lecture in 7.2 talks about measures of dispersion. And we're going to study this because it has to do not with qualitative but quantitative data. Now, when we're looking at quantitative data, that's when we're going to look at numerical. We're going to find values. And right now we're not going to find values for this measure of dispersion, which I would rather prefer call it spread. We're just going to look at it graphically, because if you think back in the first lecture, we talked about how we would graph qualitative data, but not quantitative data. So now we're going to look at a picture of quantitative data before we actually analyze it numerically. So if I was just going to do a frequency plot, sometimes this is called a dot plot or a line plot. All it is a number line, and you start the number line depending on the data that you're going to collect. So if I'm just going to collect the number of children that we all might have, we know that we can start this number line at 0, and then we just equally space. And we know that we're going to put integer values on this number line because we can't have a portion of a child. We either have one or we don't. And so how we mark this is we just put an X or a dot depending on what kind you're going to use. And if I know a lot of us have 0, notice the dot should be the same size and equally spaced. Maybe we have someone with 1, I happen to have 3, and maybe we have somebody out here with 7. Well, if you look at that, you can identify the spread. It's pretty spread out. We go from 0 to 7, and we think here it looks like an outlier with 7, possibly with 3, but most likely with 7 there's going to be an outlier. Now we have a formula that finds and identifies if something is an outlier or not. But again, that's going to come later. Right now, visually, I can look at the spread. I see we're kind of all bunched between 0 and 1, and then really spread out with this idea of 7. And that's an easy one, and that's when my data is what we call discrete. Discrete data is countable. It's not continuous like measurement, which we've studied earlier as well. This is discrete. It's countable. Histograms are used for large sets of data. Again, they have to be quantitative. And if this is often good if my data is a measurement, which is called continuous data. Continuous means that it never stops, and you'll see why that is helpful with a histogram. My class width, again, they must just be like a bar graph, equal length. And in fact, a histogram somewhat looks like a bar graph. Frequency table. We make a table to help us guide us in our histogram drawing, and a frequency table is the number of times a value lands in the interval. Now, what's an interval? An interval is just the class. And the class is kind of like a bin. What we're going to do is, I may have all these little bins here, and depending on their size, they may land in the first bin, the second bin, or the third. And this bin just starts piling up and tells me how many are in that bin. It doesn't tell me the exact value, it just tells me how many are in that bin. And the modal class is going to be the class that occurs the most often. If you remember, the mode was the most from our measures of center. But again, we like to use it with qualitative data. So here's a survey of 20 SKC students and their GPAs. We're going to construct a histogram with 4 classes. So my class is going to go, I'm going to put a parentheses, a 0, a 1, and then a bracket. Now what you have to realize is the bracket says to include. So this bin goes from 0 to 1, including anything with a value of a 1.0 GPA. So my next bin is going to be anything after a 1, but not a 1, all the way up to a 2, including all the 2s. And then my third class is going to be 2s to the 3s, including the 3s, and then a 3 to a 4.0. So when we start to tally, all I'm looking for here is this obviously fits in the first bin. A 1.4 fits in the second bin or class. 2.9 fits in the third. 2.7 in the third. 3.2 jumps down here. Now when I get to a 4, it's going to go in the last class because I said a 4.0 lands in there by the bracket symbol. A 2.5, a 3.75 would be in the last. And if I continue this process, I believe you're going to get these tally marks. Now remember, when you tally across, that would 5, so there should be 6 there. And I believe in this class there were 10. Now, if I count the number of pieces of data here, I have 1, 2, 3, 4, 5 by 1, 2, 3, 4, so there's 20. I said there would be 20. And if I total my tally marks, I have a 10, a 6, a 3, and a 1, which totals 20. I like to total to say, oh, I've accounted for everyone. Now what we need to do is somewhat look like it as a bar. So we're going to start from 0 to 1 to 2 to 3 to 4. And in my first bin here, I have a total of 1. And in my second bin, I have a total of 3. So you can see how many are falling in there, but not their value. If you're on a frequency plot, let's go back for a moment, you can actually identify the value themselves. Here you can't see the values of the data. So now I'm going to go up 6. So I'll just get a different color here. No, it doesn't have to be a different color. I'm just trying to show you here. And then the last one, it looks like I need to go up to 10. So if I was to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, assuming that was the same height, and you can see your modal class is, a lot of our students land between a 3 and a 4.0. So that's the continuation of the lectures for 7.1. So don't forget, you still have your exploration to do, which is on Excel with your small bag of M&Ms.